Hey guys, I'm going to go over some more information about pendulums. This is going to be review for you. And it's how we can find out how fast the pendulum is going when it reaches its lowest point. This is a common multiple choice free response question. So first I have a pendulum it's 2 meters long and it's displaced 60 degrees from equilibrium and released. And I want to know how fast it's going. The first thing that I'm going to do is I'm going to say that when the bob gets to the lowest point, I'm going to say that's our 0 point. So I'm interested in how much I lift this up here from the center of mass to the fixed point is L there. From the center of mass to the fixed point is L there. L ends up being 2 meters. What I'm going to do is I'm going to make this into a right triangle. And I'm going to solve for this side because I know that this side plus y is equal to L. And then once I do that, I can do conservation of energy because they don't tell us there's air resistance. I'm going to assume that there are no non-conservative forces. All right, so to get x, I have this angle, and the hypotenuse, I'm going to use cosine. So I'm going to say that cosine of 60 is going to be x over L. And so L is going to be x cosine 60. Sorry, x is going to be L cosine 60. So y is going to be L minus x, which is going to be L minus L cosine 60. This is always what your height is in these problems, L minus L cosine 60. Cosine 60 is nice because it's 1/2, so I have L minus L over 2, which is L over 2. All right, then I'm going to conserve energy. I have no non-conservative forces. When I'm at the top, I have potential gravitational energy. When I'm at the bottom, I have kinetic. The mass would cancel out. I'd multiply by 2 and square root, and I'm going to get a speed that is radical to gy, which would be 2 times -10 times y, which was L over 2. Remember we said this is 2 meters. Which is just going to be 1 meter, which is going to be the square root of 20, which is 4.5 meters per second, plus or minus. All right, one more example like this. A 10-meter long pendulum is displaced 37 degrees from equilibrium. If it's released, how fast will it move as it passes through the lowest point? Again, the nice thing is your mass cancels out. I'm going to set this equal to y equals 0. I'm going to extend a line over here. I'm going to make this x. I'm going to say that x plus y is equal to L. So y is going to be L minus x. I know this is 37. So I'm going to say that cosine of 37 is x over L. X is going to be equal to L cosine 37. So y is going to be L minus L cosine 37. We said that L was 10, so I'm going to have 10 minus 10 cosine 37. Make sure your calculator is in degrees. So I have 2 meters. I'm going to conserve energy because unless they tell you there's air resistance, there's not. Our convention is that there's not air resistance. And I'm going to say that my potential energy is going to become kinetic. I have mgy equals 1/2 mv squared. I'm going to cancel an m, multiply by 2 and square root. And I have 2 times 10 times 2. I have the square root of 40, which is going to be 6.36.